Everyone. So today we will be learning how to do the Doolittle method. But before we go to that part, let's go first and have a review of what matrix multiplication is. So we have to do this because it's very important that we understand how matrix multiplication is being done, because if not, we will then be confused as we go along with the Doolittle method. So here, this is just a quick review. For the C11, we can find the value for C11 by multiplying the first columns of the first matrix by the first row or the rows of the second matrix. So it's a summation. So this is how the quick formula looks like. So the first column of the first matrix multiplied by the first row of the second matrix added to the second column of the first matrix multiplied by the second row of the second matrix, and so on and so forth. So it's important that we understand this because again, if we don't, we will have a hard time of understanding how to do the Doolittle method. Now, going to the Doolittle, so just to give you an overview of what this process is all about. So this is being used for us to get the values of the unknown in a systems of linear equations. So let's say there are three unknowns, then we will be creating a 3 by 3 matrix, and for four unknowns, 4 by 4 matrix, and so on and so forth. And there are three critical steps that we have to follow in order to retrieve the values of the unknown. So the first one is L multiplied by U is equals to A. So that's lower triangle times upper triangle is equals to A. Then the lower triangle multiplied by Y is equals to C. And then upper triangle multiplied by X is equals to Y. So the values that we will be getting at this part for the X are the values of the unknown. So this is how the lower triangle, the upper triangle looks like. And this is how the first steps as well looks like. Now, let's do a quick review of the multiplication. Let's retrieve um, the formulas for A11 until, let's just do A33, since we will only be dealing with the 3 by 3 matrix for this video. So for A11, for us to get the value for A11, you just have to multiply again the first row by the first column. So that's U11 times 1 plus, and we will see here that it's all 0, so just leave it as it is. Now let's do the A21. So for the A21, what we have to do is we have to multiply the second row by the first column. So you would see here that we will be multiplying L21 by U11. And then again, we won't be adding anything else because the rest are all 0. So let's move to A31. A31 is being computed by multiplying the third row by the first column. Again, it's a summation. So let's do L31 multiplied by U11. And again, the rest are all 0. So these are the formulas for the A11 to A31. Now let's do A12. So to retrieve the formula for A12, again, you have to multiply the first row by the second column this time, since this is A12, that's row column. So for A12, that's 1 times U12, or the U12, this one. And then we're going to add, okay, so since these are all zeros, so let's just leave it as it is. Next is A1, let's do A22 first. For the A22, this is the row column, so you have to multiply the second row by the second column. So here, you would multiply L21 by U12 added to U22 plus or times 1. And again, the next step is 0, so we're not adding anything else. So let's go to A32. So for the A32, you have to multiply the third column by the second, or sorry, yeah, the third row by the second column. So that's L31 multiplied by U12, sorry, plus L32 multiplied by U22. We're using parentheses so that you would see what's the difference as we do the multiplication and the summation as well. So let's now do the A13. So this is row 1, column 3. So you have to multiply the first row by its third column. So that's U13 times 1. Then the rest are 0. So let's move to the next. A23. That second row multiply by the third column. So that's we multiply first L21 by U13 plus U23 multiplied by 1. For A33, so you have to multiply the third row by the third column. So that's L31 multiplied by U13 plus L32 multiplied by U23 plus U33 times 1. So the reason why we have to do this is because we will be placing these all in Excel, and this would make our lives easier since we already know the formula. So let's go ahead now in the Excel. Let's create another one here. So we're going to put here enter the unknowns. So let's put here x, y, and z, and the constants. So let's create or let's highlight this first with yellow together with this one. So the users would know that this is where they will input the numerical coefficients of the mentioned variables. Again, I mean, this can change from A, B, C to E, Y, X. Just remember that same variables should be placed in the same column so that you can get the right answers as we proceed with the Doolittle methods. So let's use an example that's x minus 2y plus 3z is equals to 10, 3x, or let's say 10y plus 10y minus 6z is equals to 21, negative 4x plus 5y plus 2z is equals to negative 17. So let's put here a reminder that we're on the first step. So based on the example, we have to create a 3 by 3. Okay. So going back to this part, so you would see here the first step here for the L by U is equals to A. The diagonals for the first part are all 1 and the rest are 0 and above it. So let's put that here. So here are all 1 and then here are all zeros. And for the next one, all the values below the diagonal are 0 and the rest have values. So let's put that here. Oh, these are all zeros. So for the part that says A, the values for these are the numerical coefficients. So let's just do a formula here. And then let's just drag this one. So whatever is showing here, that's also what should be seen at this part. Okay, now let's proceed with the formula that we did. So the first one, the A11, it's computed as, it's just equal to U11. So we can therefore say that this is just equal to, sorry, A11. U11, this one is just equal to A11, so we can just put that as a formula. Now let's proceed to A21. Again, A21, A21 can be solved, or we're actually looking for the value for L21, which is this. So let's derive the formula for L21. L21 is equals to A21 divided by U11. So let's find what where A21 is. So this is A21 then we have to divide by U11. So this is A21 divided by A11. I'm sorry, I'm working on this formula is L21, so it should be placed here. I'm sorry. So let's divide this divided by this one. Now here, the next thing that we have to solve is the L, well, this should be L31. You have to find L31, which is this value. Since on this table it is unknown, so for us to find L31, we simply divide A31 and U11. Take note that A31 is this and U11 is this one. So let's divide -4 by 1 or the U11. Now, for this one, since we're now looking for U12, so this is U12, you would see here, I'm sorry, this should be placed here. Sorry. Yeah, this should have values. I'm sorry. So let's just review here. For the upper triangle, the diagonals and above it should have values and the lower part should not have any values. So moving on, for the U12 part, for us to find a U12, it's just equal to A12, which is this. So let's just create a formula for that. Now let's move to U22, which is this. To find the value of A22, we can create the formula here. So you would see here that transposing this term to the other side, you can find that A22 is U22 rather is equal to A22 minus the product of L21 multiplied by U12. So let's do that one by one. So A22 is this one. So we can simply put here A22 minus this is L21, which is this multiplied by U12. So for this part, it's 3 times -2. Okay. Next that we have to find is L32, which is this one. Now to find L32, we can simply see here that we just have to transpose this term and then divide it by U22 so we can isolate L32. So doing simple formula here, you would see that that is A32 minus the product of L31 and U12. Everything is divided by U22. So let's do a quick formula here. So again, that's A32. So this is A32. We're looking for L21. L32 rather. So that's A32, which is this, divided by, I'm sorry, minus L31 by U12. So that's L31 by U12. So that's -4 times -2. And everything is divided by, let's confirm, that's U22, which is this one. So that's 16. So that's the value. Now let's proceed on finding these values. So for this one, this is U13. So you would see here that U13 is just simply equal to A13. So that's that part. So let's just equate this to this. Now to get the value for U23 rather, since we're just doing a 3 by 3 matrix, we can simply isolate A23 and then move the product of L21 and U13. So let's click a formula here. Again, that's A23, which is this one. So that is 6 minus the product of L21, which is this one, and U13, this one. So that's L21 times U13. Let's take a look. It's L21 times U13. L21 times U13. A23 is L21. Since we're looking for the value of U23, alright, let's change the value here to -6. Sorry, I wrote the wrong equation, so the equations should be x minus 2y plus 3z is equals to 10, and the second equation is 3x plus 10y minus 6z is equals to 21. The third equation is negative 4x plus 5y plus 2z is equals to negative 17. So going back to the last unknown here, so we're looking for the U33. So isolating U33 here is that this is A33 minus L31 multiplied by U13 minus L32 multiplied by U23. So let's go and get the value. So that's A33. So this is A33 minus the product of L31 and U13. So this is L31 U13. So L31 minus or times U13 minus L32, which is this, multiplied by U23. So there we go. So we can see here that we are already done with the first step. Now let's move to the next step. So as we can see here on the formula, going back to the PowerPoint, that this is L multiplied by Y is equals to the constants. So here, let's create a 3 by 3 matrix, and then these will be the values for the Y, and the constants will also be this. So we would see here that where the constant is just a 3 by 1 matrix. Therefore, having a 3 by 3 multiplied to a 3 by 1 would only make this specific product possible. So going to the formula, the values for here are all constant. So let's just copy this one and then drag. And then for this one, since this is our all L, we can just simply create a formula making this equal. Okay. Now, for this part, again, we have to recall on how we are doing the matrix multiplication. So you would see here that we can find first the value for this one, the first part. So we can find this by solving or relating it to the first answer for this part. So 10 can be retrieved by multiplying. Since this is A11, we will have the same formula for A11, which is, let's go back here. A11, this is U11, right? This is U11 times this value. So we can simply isolate U11, which is this part, into A11, or the value here, divided by 1. Or we can just simply equate this rather to this one, since multiplying this row by here would give us 10. Now let's go to the second unknown, wherein we will be getting the values for this part. So for us to get the value here, we will be multiplying the second row by the first column. So that's 3 times 10. Right, so we will be multiplying this to this one. All right. So for us to get the value for this one, we will be multiplying 3 times 10 plus 1 times y sub 2, and then 0. So we can just simply create a formula here wherein this minus the product of this and this. Now for the last one, for us to retrieve the value here, we have to multiply the row here by the first column, and the answer is negative 17. So for us to get the value here, we can just simply equate this to negative 17 minus the product of negative 4 and 10 minus the product of this and this. There. So now that we have found these values, we will be moving to the third step, this one. The third step here, going back to the PowerPoint, is upper triangle multiplied by x is equals to y. So upper triangle, it's again a 3 by 3 matrix. So again, this is the upper triangle, this one. So let's just copy and paste this. Sorry, the value will change. So we have to remember to equate this one here, then drag, then drag. Now for this one, the y, we can just simply copy and copy this one. So remember to equate this to values here. Sorry, just drag it. So again, we will have the same concept here since this is just a 3 by 1 matrix. The answer here, or the 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 m by n matrix that should be placed here is also, or should also be the same as this one. So again, based on what we explained a while ago, that the values that we will be getting here are the values already of the unknown. This will be the x sub 1, x sub 2, y sub 2, or for this example, this will be the x, this will be the y, and this will be the z. Now on this part, based on to what we have done for the first and second step, what we normally do is we start from the top going to the bottom. Now let's start for the bottom going to the top, since the third rows here are all zeros except for this one. So we can just simply create a formula here wherein we will be dividing 21 by 11.1875. Now let's move here. So for us to get the value here, we just simply have to multiply or to subtract the answer to the values that we will be getting from the product of negative 15 and this one divided by the coefficient, should place it here because everything has to be divided by 16. Next, for us to find this one again, for us to um, get the answer for 10, what we have to do is multiply the first row by the first column. Therefore, for us to get the value for this, we have to multiply 1 times this plus negative 2 times this, then 3 times this. So to isolate the value here, we just simply this one, subtract it to the products of this and this, subtract it from this one. Let's check and confirm. Oh, sorry. This shouldn't, this should be this. There you go. So now that we have gathered here, so the formula or the process ends here. We have now retrieved the values of the unknown at this part. So we can continue getting more or trying this Excel formula that we have for us to make sure that the results or that the formulas that we have entered will give us the correct answer. So let's go ahead and grab some examples online. So let's look for a 3 by or solve for 3 unknowns. let's get for some examples here. So this one. So these are the equations. So we can put here 7x plus 5y minus 3z. So that's 7, 5, negative 3, 16. Second, 7, 5, negative 3, and then 16. And then 3, negative 5, 2, and then negative 8. And then 5, 3, negative 7, and then 0. So based on the formula here, our answers should be 7, 3, and 2. Now, let's go ahead and use an online scientific calculator. Um, let's look for online unknown um, with 3 unknowns. So this is an online calculator. So we can enter here the values that we found here. Hey everyone, so on the example a while ago, we found that this is incorrect. So I double checked the formula and I found out that we forgot to divide this by the value we find here. And with that, that gave us the correct answer for the values of x, y, and z. This one, 3, and 2. Now let's use another example. Let's say, let's give this calculator into test by giving random answers, or given rather. 8, and then this is 52, this is 4, this is 4. So let's put these values here. So this is 4, 5, 4, negative 8, this is 52, it's negative 8, this is 4, 2, and then 4, this is 4, then negative 8, then 4, and then 4. So let's hit enter. The values are negative 31.5, negative 39, and negative 45. So we found the same answer. So basically, that's it. So we have to be careful on the formulas that we have here because, of course, that would make the difference. But above all, that's how we do the Doolittle method. You just have to make sure that you have an understanding of how the matrix multiplication is done because that's the vital part of this process. Because if you're confused at that part, then you will then be confused with the rest of the process. So again, this is just a quick overview again before we end the video about the matrix multiplication, and same goes to the Doolittle. Remember these 3 steps and remember how we find the values. So by the way, this continues as we get more matrix. So just remember that if you have more unknowns, that corresponds to the number of the matrix that you'll have. So if you have 5 unknowns, that should be a 5 by 5 matrix, and therefore the L or the lower triangle should have like continuous one, then the rest are above it are zero. Then that you will just have your L5 1, L5 2, L5 3, L5 4. And then same goes here. This will be a 5 by 5 matrix, so the rest will all be zero, and you'll just have to continue here A5 4 and values above, and same goes with this one. So that's it. That's it for Doolittle numerical methods. Thank you.